All right, so I have the honor to start, or to kick off actually, the developer track. And we have a couple more sessions lined up. So this will be an overview talk. And then we have deep dive sessions about real-time mobile games with AI. How hard can it be? We have another talk about desired state, contain your containers from Mandy Wade. And then we have a talk about your data and the world beyond map and reduce with Felipe Hoffa. Next, besides these talks, we have a workshop area which is over there where you can take self-paced code labs. We have experts there we have table topics there with experts about Node.js, about Python in the Google Cloud Platform. So you feel free to swap and go and have a look and talk to the experts while they are here and they are at your dispense. Okay, a little bit about me. I'm Robert Kubis. I'm a developer advocate. I'm actually based here in London since recently. You find me on Twitter and on GitHub under the handle HostyRosty. And the picture that you see up there is my hero moment, actually. It was the day that I got my private pilot license. And I want to take this metaphor, so to say, of flying. So if you cruise at a couple thousand feet altitude, you have a really nice overview. You see landscape, you see lakes, you see mountains, you have a nice overview, but you don't see details. So especially if you want to land at an untowered airport, you want to see what are the conditions and are your requirements fulfilled. So you do a low overfly and you check if there's anything on the runway, if the forecast of the wind is true, or is that what you see down there. And I want to take this actually into this talk. So we always getting back to an overview of the architecture, and then we do a little bit more detailed deep dive into certain components. All right, so imagine a bunch of Googlers having 4 weeks, getting into startup mode, and having to create something exciting. So we didn't want to give the usual overview talk where we go through each of the products, and in a monotone and unexciting way, we tell you about what they can bring to you. We wanted to have something exciting. So we got together, we did a couple iterations to come up with a real nice thing. And we called it Cloudspin. And I'm sure many of you have seen it already out there while you were having lunch. So before I go into the setup, what we did there, I actually want to know how many of you are developers. That's awesome. You are at the right place because this talk is actually for developers. So what did we come up with? So we come up with that we wanted to freeze the hero moment, so to say. We wanted to have a still image of the hero moment, and that in from 180 degrees. So we took some commodity hardware. We took actually Nexus 6. We placed them at equal distances in a semicircle. And the user gets in the middle, and we freeze the moment. So, all right, so here a little bit more abstract. The user gets in the middle. We have all the phones. We are getting the system ready. And once the user does something crazy, like a jump or a pose or whatever, we freeze this hero moment. So you might see, or you might notice actually right now that we display a lot of pictures for each phone there. And the reason for that is, it turns out it's really difficult to synchronize 19 phones to take a picture in the exact same moment. There is probably a way to get it working, but we didn't have enough time. So we were looking for a workaround. And the workaround that we did is actually we're taking a video, and then we are using an audio cue that we trigger at the moment we want to have the hero moment be frozen. All right, so how does it look like from a perspective of one camera? So here is one of the videos, and you will hear the tone. Or you won't, because I didn't plug in audio. So let's try this again. So you see me jumping, and you hear the tone. So what happens at the moment that this tone is playing, we extract that frame, and of course we are extracting that for all of the 18 phones that we have. And then we're stitching them all together, and that is basically the end product. All right, so we are, like many of you are developers, you want to know how that works and what we did and what we used. So here's the high-level back-end architecture. We are having devices, which are our Nexus phones. They are taking the video. At the end of the video, they are uploading them to a storage system. And then a whole processing line gets triggered. And at the end, the 180-degree GIF is the result and gets stored again to a storage system. All right, so let's dive in. Let's do our low overflight actually, for the video uploads and notifications. So let's concentrate on the left side here. We have the phones that upload the videos, and we don't want to have any more burden on the phones. So they are not like our controllers. So their task is really what they're doing well, taking a video and uploading the video, and then their task is basically done. And then they are waiting basically for new instructions. So what are our requirements for this part of the demo? We want to have a storage that can store a large amount of data in a secure way. We want to have immediate access to it and strong consistency. And we want to have also the storage system taking care of triggering the process pipeline afterwards, like what comes after uploading the videos. So for this, we choose Google Cloud Storage because it gives us the ability to store large amounts of data, large amount of unstructured data. It can be up to terabytes per object. And all these data is encrypted at rest. We have a strong consistency. So you have strong consistency read after write, read after update, and read after delete. They are geo-redundant replicated. So once they are replicated, they are available all over the world and really quick. And we have what we need for our demo is we have change notifications. Some other features that are given with Google Cloud Storage is fine-grained access control, as well as versioning and resumable uploads and downloads. Okay, there are several options that come with Google Cloud Storage. All of them, and that's a high priority for us, is durability. We don't want to lose any of your data, and we make sure we give our best to not lose any of our data. So that's why you see for all the three options that we have there, the durability bar is all the way to the end. But you can choose between throughput, which means speed, and availability, so time to the first byte. And depending on like what are your requirements are, you can save money. So the standard storage is our fastest solution. You have the highest throughput, and you have the highest availability, given by that we have a lot of replicas. If we're reducing the replicas, we call it durable reduced availability storage, which means it could take a little longer to get your first byte, but you still have, it's still pretty quick, and you still have a good speed, and we are giving the savings to you. The new technology, which we call Nearline, we aim to replace traditional tape backups. So it has lower throughput. Throughput is depending on the amount of data that you store. And it has lower availability. So it can take a couple seconds till you get your first bytes. But compare a couple seconds to hours, to days, or even weeks to restore backups from tape, right? So, and again, this is comes at a very affordable cost. So let's go into the detail for our demo. What did we do? We created a cloud storage bucket. Let's call it my input bucket. And we wanted to have a notification sent once something changes in this bucket. You can do that with a single command on the CLI, and you use gsutil. You register the endpoint where the notification is sent to, and you name the bucket, which is a global naming scheme. You name the bucket where the notification should be triggered. So this registers, you do that once, and then it's done. And now if a client, in our case, the phones, are adding videos, every time the upload is finished, a change notification gets triggered. And that basically is a JSON document that gets sent to the endpoint that you registered. And it has data like the name of the file, the bucket name, creation time, an MD5 checksum, and stuff like that. Another cool feature that we offer with Google Cloud Storage is so-called edge caching, which gives you the ability to use Google front ends for caching. So what does it mean is we are trying our best to bring the assets that you're delivering to your users close to your users. So if somebody in Africa, somebody in Australia, or in Vietnam downloads static assets for your web page or your application, we are trying to serve that from a closest point. Now, this is not a guaranteed cache because resources are limited, of course, but we're trying to do our best to get the best for you. All right, so we have covered the Google Cloud Storage, and you see we are using that for our input bucket, where all the video is coming in. And we are also using this for our output bucket, where the end result, our GIF, is being placed. Let's dive into the notification. As I said, you register an endpoint for your notification. So this notification needs to be able to process HTTPS post requests. We also want to avoid that anybody of you could just send randomly notifications to our process. So we want to have that secured. We want to have authorization and authentication, and that in a simple way. And the other thing is we want to have logic, execute logic, because we have to trigger the rest of the processing pipeline. So we want to be able to process and do something with that request or that notification that we get from the Google Cloud Storage bucket. So for this, we choose Google App Engine. Google App Engine comes with a choice of runtimes. So by standard, you can do Java, Python, Go, and PHP. It's very easy to develop. So you can download an SDK and can develop on your local machine. It gives you versioning. It gives you traffic splitting, which helps you with, for instance, A/B testing. And the coolest thing, it's fully managed by us. It's fully managed by Google SREs 24/7, which means if anything goes down, we are taking care, and we hope that nothing goes down, but we will take care of resolving the issue. So you don't have to manage anything. And we are taking care of scaling for you. So it doesn't matter if you want to scale out or you want to scale in. If your demand goes high, we are scaling up. We're scaling out. If your demand goes down again, we are scaling in. All right, so the traditional app engine is a sandbox environment where it comes with a sandbox runtime and a web server and then your user code that you upload to that. This is restricted to the languages that I mentioned before, Java, Python, Go, and PHP. But we also have a new form of app engine, which is a containerized app engine environment, which allows you to, on one hand, bring or use our provided runtimes, but also bring your custom runtimes. And that allows you to install libraries and packages and all these things. But you have to provide us a couple of hooks so that we can manage your application and can give you the goodies of scaling and availability. So for our demo, we choose to write an API endpoint for our Google Cloud Storage bucket in Go, because one of the demo creators, he is a gopher, he's all over Go. So he wanted to use his primary language, and he could choose and use Go for writing this API endpoint. All right, so once we have received this notification and we have processed it in our Go App Engine endpoint, we are kicking off the processing pipeline. So you see here that we have an extraction and stitching and then basically the saving to the output bucket. So what are our requirements? We want to have asynchronous messaging, so we want to decouple the components as much as possible to allow for scaling, availability, and stability. We also want to allow pull subscription, which allows us to like throw a bunch of workers, so to say, at a work queue where they can pick up their work by themselves. And for that, we choose Cloud PubSub. That gives us a reliable real-time messaging between applications. It's asynchronous, it is many-to-many, it is global, it works. This is actually the infrastructure that we use internally at Google as well. So we make sure that this is available, this is stable, and this is working for you. It allows you, like, it's designed for fast data, so low latencies, and a lot of data that you can send through this. So let's look at the detail how Cloud PubSub is constructed. So you have publishers and subscribers. So publishers where the messages are coming from, and subscribers where the messages are going to. You define topics, which are basically your channels, and you let the publishers push messages onto a topic. Now, you have different modes that you can get these messages out of your topic channel, and that is, on the one hand, you have pull and push subscribers. On the one hand, like where they pull the message down from that topic, or where they get the message pushed from the topic. So what are the clients that we are supporting? It's a simple HTTPS REST API. There are a couple of implementations for Go and Python out there which make your life even easier. But so you have authentication supported, you have Google Cloud Platform apps that can send messages to the topics. You have desktop apps that can, native desktop apps that can send messages. But we also have browser apps that can send messages. It's just each HTTPS REST. For the subscriptions, for the pull subscription, we support the same set of applications that we are supporting for the push. But for the push to the topics, for the push subscriptions, we are actually pushing the message to a client. So a client subscribes to a topic, and every time a message comes in, we are pushing that message to that client. And currently, we are still beta. We're currently supporting only Google apps in the Google Cloud environment. All right, so what can messaging or Cloud PubSub do for you? On the one hand, it can give you availability. So it buffers new requests. It prevents overloads, so you can basically do throttling. And it helps you to redirect messages in case of like disaster recovery. It also gives you the nice ability to handle the throughput in a way that you can smooth out spikes. So if you have a lot of, let's say we use our demo setup and we are installing it in many cities around the world, and maybe even many cities in London. So you have suddenly a lot of videos coming in. And maybe our extractors didn't, like, at that point, like, scale up to the point where they can handle all these videos. So you can use Cloud PubSub to throttle what you're actually pushing to the stitcher, or like how much the extractors can pull. So for the demo, we have 3 topics. The one topic is logs, where I will not go into details. We don't have the time right now. The other 2 topics are the extract topic that we see here. So basically, our App Engine endpoint is pushing a message to the extract topic, and we have a bunch of workers that are listening in on this topic. And whenever time they are free and they are available to process something, and a message is available on the extract topic channel, they are pulling that down and working on it. So now some of you might ask, like, okay, what happens if they pull down a message and then something fails? Is this message lost? So to tell you, it's not. What happens in the way, like, you can set actually a timeout till when an acknowledge is expected. So if our extractor workers are pulling down a message and they are not acknowledging having this message processed in a given time frame, we are putting this message back onto the topic, and a different extractor can pull it down. So this gives us basically the fail safe. The same is also for if you have the push mechanism. So if you get like a message push to you, you also have to acknowledge it that you process the message. Otherwise, it goes back on the topic. So for our stitching, we use the push mechanism. So every time an extractor is finished with extracting a frame out of the video, it's pushing that frame, so basically the status that it's finished, onto the stitching topic. And the stitcher gets a push message and looks like, okay, all frames are available. And once all frames are available, it can start and stitch them all together. So now we talked about the messaging, which is kind of the glue part between the processing. And for the processing, as mentioned, we have extractors and stitcher. So you might think like, yeah, we can probably use Google App Engine again, and we probably could, but we wanted to do something different, and we wanted to use the qualities of the demo creators. So we wanted to have the ability for long-running services and being able to scale. We wanted to have a secure subscriber and publisher to the Cloud PubSub topics. And we wanted to have a simple way to develop and manage these extractors and stitchers. So for this, we choose Google Compute Engine, which gives you compute resources in 3 different regions, in the US, in Europe, and Asia. It's backed by a fast software-defined network. We provide you with sub-hour billing, so you're not getting billed by the hour. The first 10 minutes get billed, and then you basically billed by a minute. We have no IOPS charges. And a nice feature is if you want to have load balance, you don't have to spin up an extra VM to actually have load balance. So we basically have load balancing as a service. It also allows you for fast VM provisioning. So we tested to spin up 1,000 VMs in a couple of minutes, basically. And the other thing, they are very well isolated. So you don't have to be worried about noisy neighbors. So if somebody is like running like a very heavy workload, they will not inflict with your VMs performance. The Compute Engine VMs that we offer going up to 32 cores and 280 gigabyte of RAM. We have on the lower end also shared core VM instances. It supports a bunch or a set of operating systems. So just to name a few, Debian, CentOS, CoreOS, SUSE, Red Hat Linux, and we are also supporting Windows in beta currently. So for our use case, we wanted to have the possibility to scale the extractors. And for that, we used a feature that's called Managed Instance Group. Managed Instance Group gives you the ability to group identical VMs. So how is this done? Basically, we have an instance group manager who makes sure that always the right amount of VMs is available for you. You set it, basically you set like, okay, I want to have 10 of these instances. And the instance group manager makes sure that there are 10 of these instances. So it will create and destroy VMs like on demand. So that the instance group manager knows what it has actually to create, what kind of VM it has to create, we are using so-called instance templates. And instance templates are a recipe for how your instance will look like. So you will define which zone is it created in, like what's the size of your VM, what operating system it is running. And then you can also define like a startup script, or you can define a container that is started in that VM. So that is nice, but like usually during development, you actually change your environment, like you update your VMs very often. So what you want to have is a possibility to actually do a rolling update. So we're also supporting that with Managed Instance Group, where you can assign a new template to your Managed Instance Group. And the Instance Group updater will take care of doing a rolling update of your existing instances. Another, like, as I mentioned, like you can set how many instances you want to have, but like, wouldn't it be cool, like actually scale on demand? So what we also support is a so-called autoscaler, that you can hook into Managed Instance Group. This autoscaler can take custom operating system metrics. It can take like standard ones like CPU utilization, RAMs utilization, and it can take custom ones as well. It can also plug into PubSub and listening to a topic basically and see like what is the filling rate of that topic and decide on like if it has to spin up more instances or it can destroy instances. So for our use case, we wanted to have like a reproducible way of spinning up our instances, and the easiest way that we saw for that is actually using a container. And we provide with Google Compute Engine, we provide the CoreOS, which is an optimized operating system for containers. So we choose to run CoreOS and deploying a container. That is also very nice, a nice pre-step for us to actually move later to Kubernetes. And you will have a talk following, not this talk, but after the next talk. There's a talk following from my colleague Mandy Wade, who will go in a little bit more detail on how to manage containers with Kubernetes. And we have an offering there which is called Google Container Engine. So now we have, for our extractor and our stitcher, we have our images and our instances running. And even though I said like we want to decouple as much as possible everywhere, we still need a little bit of coordination. So here's the coordination part. So what do we need? On the one hand, we have people signing up to to freeze one of their hero moments. So we have the sign up part, we get like everything ready. The videos are uploaded and the extractors getting to work. So now the extractors are actually putting the frames that they extract back on temp storage for now. And they are storing a state that they are done with that frame in a DB. So for this, we call it right here, we call it online DB. And they are also sending a message to the stitcher topic and saying like, hey, a frame is ready. So now the stitcher is getting the push message and looking, okay, I got a new frame. Let's see if all the other frames are ready. And then once all the other frames are ready, the stitcher can actually go to work, get all the images, stitch them together, and put them back onto the bucket. And for this, we used an amazing product called Firebase, which we acquired in October last year. And that allows really beautiful synchronization between many, many clients. And we actually have a talk right after this talk, real-time mobile games with AI, with my colleague Terry. And okay, so we have basically all components of our demo together. So I want to ask, like, how many of you have seen a live demo failing? All right, awesome. So because we think like, okay, a failing live demo is nice, but we want to go actually one step further. And we are going to do a remote live demo of that setup. So give me a second, but basically I'm calling my colleague, Alexis, that I hope is ready. Let's see. Okay, we're starting the Hangout. And all right, let's see if Alexis is there. All right, hi Alexis. Awesome that I get you. So here you see my colleague Brad actually in the middle of the setup, of this demo setup. And Brad, can you wait for us? Yeah, awesome. So you see it's live. Wi-Fi is holding up. Awesome. So you see our phones that we placed in equal distances on that rig. We have 18 phones, and at the middle we have our operator terminal, so to say. We have a tablet there which controls all the phones in a way that it's basically telling them to start taking a video. So you see all the phones were green, so they were ready to do something. Now they are in the yellow state, which means we give them a countdown, a time where they should start recording. And they all get blue. You probably saw it. You saw my colleague jumping. We are triggering the audio signal. And then Alexis is walking over to the dashboard where you actually can see what is happening. And let me actually go over here, and let's hope this is working. So you see here on our dashboard, all the cameras or all the Nexus are now uploading the video. So let's hope, and as to mention for you, the uploading takes that long because it's Wi-Fi, and all these phones are using basically Wi-Fi at the same time, and uploading, each of them uploads 10 megabytes. So we have 180 megabytes that we have to pipe through the Wi-Fi here. And you see them coming up, and as soon as they are on our storage bucket, they are getting processed. So the extractors are picking the videos and extracting the moment. And Alexis hit a beautiful moment here. We see Brad in the air. We're seeing more and more of the frames being extracted. 2 more to go, and let's hope the last one works as well. Let's see if we have the demo effect. And we have, hopefully, a successful live demo. We have a successful remote live demo. Awesome. All right, so back to these slides. Of course, I don't want to forget to mention and giving, because this is my demo backup, by the way, in case it wouldn't have worked. So yeah. All right, so in summary, what have we used and what have we learned in the session? We have learned about Google Cloud Storage. We use that as for storage for our videos and the GIF. We have learned about App Engine, where we built our API endpoint for the change notification. We have learned about Cloud PubSub, which we use as the glue in between to build a scalable and reliable system. And we have shown you Google Compute Engine, as well as how we made ourselves already ready for transitioning to Google Container Engine. And last but not least, we also showed and introduced Firebase, which we use for the coordination of the whole system. So I want to give credits to my colleagues that built the demo. You saw Brett actually in the demo rig right now, so he's live here. You can go to him and talk. You can come to all of us. We usually wear one of these T-shirts, or we have a badge which says Google. Frances Campoy, who is our Gopher and Go expert, Casey Kem, who did all the project management, and Ray Thang, who did the visualizer and also helped with the Android apps. All right, that's it for my talk, and thank you for your patience and your attendance, and I hope you will have a great following afternoon with the 3 more talks that are following, as well as the code labs and the table topics that we have. Thank you very much.